Hey everybody, we're going to talk about general angles and using radian measure today. So let's jump in. We're going to be starting to talk about these angles. So the first thing we want to talk about is what it means to have something in angle and standard position. And that just means that if the angle's vertex is at the origin, remember the origin is just 0, 0. So we would have the vertex at the origin, and its initial side is on the x-axis. So let's draw a angle where it starts right here. We call that initial side. Okay, we say it's starting side of the angle, and the terminal side is the ending side of the angle. So let's just say it's right here. So we know the blue is the initial side and the purple is the ending or the terminal side. Then this is an angle in standard position. Okay, so here we go. There's our angle in standard position, and that just means that the vertex is at the origin, its initial side is on the x-axis, and it will end somewhere on that xy axis. So if it says draw an angle with the given measure in the standard position, so if we're looking at 240 degrees, I know I have to start here, that's its vertex, and its starting position, we say that this is 0 degrees. So if I stay right here, this is an angle in 0 degrees. I know right here is an angle at 90 degrees. So I'm just going to mark this right here. It would be 90 degrees. And if I know I went from straight here to here, that would be 180 degrees. So I know if I went from here to here, this is 180 degrees. But I need 240 degrees. So I know 240 degrees is 60 degrees more. So if we went 60 degrees more, this is our 240 degree angle. And again, it starts vertex here. Here's our initial side, and then we're going all the way past 180 degrees back over here to 240 degrees. So that's in red for number 240. Let's do 500 in, let's go ahead and do that one in green. So 500 degrees. Now remember, a full circle is 360 degrees. So we know we're going to have to go more than a full circle. We're going to have to go 140 degrees more. So if here's my vertex, here's my initial point, I'm going to go a full circle 360 plus, a full circle 360 plus 90 is 450 plus a little bit more, 40 degrees more than that is about 500. So I know 500 is going to be a full circle plus another 140 degrees more. Okay, and then lastly, let's do this one in blue. Let's go negative 50. Now negative just means we're going to go in the opposite direction. So instead of being counterclockwise, it's going to be clockwise. So again, here's my vertex, here's my initial side. It starts on the x-axis, and we're going to go this way 50 degrees. So I know from here to here is negative 50 degrees. Let's talk about coterminal angles. And coterminal angles are just simply two angles are where they have, two angles have the same terminal or ending sides. So for example, if I'm drawing this, and if I have an angle that looks like this, okay, so there's my angle. I could also have an angle that also starts here on the terminal side, but if I went this way, it's a negative angle, and it ends right here as well. Do you see how these both end on the same ending terminal side. So these are co-terminal angles. So basically, I can start at the same one here, and I can either add a circle or subtract a circle. So if I have that same angle here, I can add a full circle and get back to it, or I can subtract a full circle and get back to it. So when I want to find one positive and one negative angle that are co-terminal, just remember co-terminal means you either add 360 degrees or multiples of 360, or we can subtract 360 degrees. So if I've got negative 450 degrees, here's my angle, okay? So I'm starting here at the standard position, and I'd go negative 45 degrees. That's going to be right here. So if I wanted to get back to that spot, I could do a couple of different things. I could start at 0 and go this way, or I can start at negative 45 and go the other way around and get back to it. So I'm going to go ahead and add 360 degrees to get a positive angle. And if I add 360 plus negative 45, that's like subtracting. So we'll get a positive 315 degrees. And then I'll start with the negative 45 degrees again, and I'll subtract 360. Now remember, if this is a minus and I'm subtracting 360, that's like saying adding a negative 360. When you have subtraction or a negative number, adding another negative, we can actually just add the two numbers and we get 415 degrees. So if I was also looking for that, that's a coterminal angle of positive 315 or negative 405 degrees. So these are both coterminal, and I'll draw it this way. If I go negative 405 degrees as well. So 45 is the same as 315, is the same as negative 405. Okay? All right, let's do the next one. Here's positive 395 degrees. So let's find 395 degrees. So I know a full circle is 360, so here's 360 degrees, and we're going to add another 35 degrees, and there's my angle of 395. So I know if I want to get a coterminal, I can add or subtract 360. So if I subtract 360 degrees, I'm going to get 35 degrees. So another way to get to the same spot is just starting at 0 and going up 35 degrees. Or we can take 395, and instead of subtracting 360, we can add 360. Now, actually, wait a minute. We need to find one negative as well. But wait a minute. The one we found before was positive. So let's subtract another 360 so we can get an actual negative number. So if I subtract another 360 from 35 degrees, I'm going to get a negative 325 degrees. So I can get back to that spot. So I'm going to start here. I'm going to put it in purple. Here's my starting side, and we're going to go a negative 360, or negative, 325. And we get negative 325 right here as well. So these are my coterminal angles. So let's talk about these angles. So remember how we've always told you, yeah, these angles, that's how we measure them with degrees. And there's 360 degrees in a circle, right? Well, in a circle, why are there 360 degrees? Why didn't someone pick a number of like 1,000 or 100? Like, what's the magic about 360? So we're going to talk about another way to measure angles, which is called radians. And radians just come from this idea that whatever angle that is, that this is a radius, that the distance that it goes on the circle, once it hits a radius, we call this a 1 radian measure, meaning that the radius equals the opening on the circle, and we'll call this unknown angle. We'll call that theta, right? We've been talking about and angle being theta. When it opens up far enough on the circle, we call that 1 radian, when it's equal to a radius. So you might be thinking like, what in the world, what are you talking about, Mrs. Stell? So let me just kind of break it down for you. We know the circumference, which, circumference is just the full circle, right? The outside of a circle we know is 2 times pi times the radius. So 360 degrees is equivalent to 2 pi radians, or 2 pi radius. Or if we simplify it, we get 180 degrees equals pi radians. So here's what you need to know. If this circle right here, we know this is 0 degrees, this is equal to 0 radians, okay? A whole circle, if I go around here, at 360 degrees is equal to 2 pi radians, okay? Here's what that means. If I were to go only halfway from here to here, and this is 180 degrees, we know that that's going to be pi radians, because it's half of 2 pi radians, or half of 360 is 180. So we need to know half a circle is pi radians, a full circle is 2 pi radians, okay? So in order to convert a degree to a radian, we take the degrees that were given and we multiply by pi radians divided by 180 degrees, and that will give it to me in radians. If we have a degree in, or an angle in radians, to convert it to degrees, we just multiply by 180 degrees divided by pi radians. And that's because pi radians and 180 degrees are equivalent. So we can convert those units. So let's go ahead and convert something. If I said to go ahead and convert from degrees to radians and radians to degrees, so this is given to me in degrees, I need to convert it to radians. So I'm going to use this right here to convert from degrees to radians. So I know if I've got degrees, I'm going to multiply by pi over 180 radians. So these degrees right here are going to cancel. And then we get 125 pi over 180 radians. Now I want you to leave this pi alone for now and just simplify the 125 over 180. And when we do that, we can reduce that fraction to 25 over 36 pi radians. Okay? And then similarly, if I've got negative pi over 12 radians, I want to convert it to degrees. So I'm going to use this right here. When I'm given radians, I'm going to multiply by 180 degrees all over pi radians. And so we end up being able to cancel the radians, you can see that, and cancel the pi, and we're left with negative 180 degrees over 12. Well, when I reduce that, I get negative 15 degrees. Okay, so now let's talk about this circle here. So we've got this circle, and I've got it broken up into these common angles here. We can see this is our vertex. We know this is 0 degrees. From here to here, this is 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, 150, 180, and so on. And these are increments of, the orange ones are increments of 30 degrees, the blue are 45 degrees, and the purple are 60 degrees. So now we're going to label them, and I want you to take your pencil, and we're going to label them in radians. So in radians, this is 0 radians. This 30 degrees is pi over 6 radians. 45 is pi over 4. 60 is pi over 3 radians. 90 is pi over 2. Now keep in mind, if you think that 180 degrees equals pi, then those fractions of getting to 180 is easier to look at those as a fraction of pi. 120 degrees is really 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. And 180 degrees is equal to pi. And then we've got 210 is really 7 pi over 6. 225 is 5 pi over 4. And 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. And 330 is 11 pi over 6. So if you need to push pause right now and fill that in, go ahead. This is going to be really important for you to use. Okay? All right, and that's it. I'll see you back in class for